Hello there. This is the fourth installment of the video for EV on the electric BMW 320i project. I've been away a couple of weeks. I had to travel out to San Diego. I visited my friends at EV West out there. Unfortunately, we didn't get any video shot, but other things at work have been keeping me away. But finally I'm back working on this again. So this week what I'm going to be showing is how I spoofed the instrument cluster. Because I want to basically make this a restored car, I want to use the analog gauges that are in the instrument cluster to display all the battery information. And I will probably put some other digital gauge like a JDL 404 somewhere or something else for the BMS. But for now I'm going to just try and run those analog gauges. And I found something really great about them. They're all galvanometric gauges, which means they just are driven by current to make them move, which means they can be very easily programmed with pulse width modulation, which is again a very easy thing to program out of a processor. So I'll be showing you that and also some of the things I've been working on. I got all the battery boxes designed and they're actually out for fabrication. So hopefully in about 2 weeks I'll have battery boxes and be able to start stuffing those with batteries. So let's take a look. Spoofing the instrument cluster. Here I'm doing the tachometer. I took the tachometer apart and found that the circuit driving it had a little integrated circuit in it that is a pulse shaper to current driver. And that makes sense because again, the gauge being galvanometric, it just wants to be driven by current and not high frequency pulses or high voltage pulses coming from the distributor cap. But I found that I didn't need to use that circuit because I could drive the tachometer directly with the pulse width modulation output from the microchip PIC, because the PIC is running at 5 volts, and that turns out to be, that's what the circuit was actually designed to run at, was at 5 volts. So in this little program that's running, it steps the pulse width modulation 5%. And it is very repeatable, goes to the exact same points each time. So this actually could be driven by anything that would do the pulse width modulation within that range. Here I'm showing the graph, and you can see it's very linear except for right at the very top. This is the PIC Development Board. It's got a lot of I/O on it, has buttons and LEDs and a serial interface, and it's very easy to program and run, and it's what I'm finding is useful, mostly because the pulse width modulation call is a single call. You just pass the frequency and the duty cycle, so it's actually a lot more versatile than what Arduino has in their IDE, where you can't really even control the frequency. But in this case I'm finding that the frequency doesn't need to be changed, just the pulse width modulation of the signal. The first of the gauges I was able to spoof was the fuel gauge, because the wires that went to this gauge were right there in the where I cut the holes for the battery boxes in the rear seat, so I had access to those wires and I could probe them and figure out which ones actually drove the gauge. And that's when I discovered that the gauge was not a bimetallic strip, which a lot of old fuel gauges were in the era of this car, but actually a galvanic gauge, in that it took current to drive it and move it, which means by pulse width modulation it's possible to make the gauge move. And again, ramping it up with using the BMW output from the PIC, or microchip PIC, this just ramps up. This is doing steps of 1 duty cycle. So this gauge is very sensitive compared to the others. Only takes a small range of current to get it to move. I think I measured 10 milliamps when I was originally doing the first testing. But very repeatable in setting the value. But I think I'm going to have to change the icon on the gauge to not a fuel pump, but maybe a battery. The temperature gauge proved to be the most difficult to spoof, and that's because the way the gauge is designed to work, it's normally has a essentially a variable resistor, a thermistor that's sitting in the engine block, and as that resistance changes, the current changes that flows through it, and that's what drives this gauge, because again, this gauge is a galvanometric just like the other gauges. Problem is, for programmatic control, that's a little difficult to have a variable resistor. So what I discovered was that if I took the 12 volts that normally supplies this gauge and drove that through a MOSFET in pulse width modulation, that I could programmatically move the gauge. And that's because what I've done is put a resistor on the output of the gauge to simulate the sensor, and that resistor is a value so that when I get 100% duty cycle, I get full gauge displacement. So this is how it works. What's interesting is those are 5% changes in duty cycle, and it looks like the gauge movement is nonlinear, but actually when you plot this of duty cycle versus position, it is linear, except for the very beginning. It's kind of nonlinear, that first step. One interesting feature of the tachometer in this instrument cluster is that it actually had a clock built into it. There at the bottom is a 4-digit 7-segment type display. Unfortunately, as it is now, it is only a clock, but I've found a display exactly that size, and I'm planning to replace that so that I can program the numbers, and therefore I can have a digital readout of all these other analog gauges. So it'd be nice and accurate. These analog gauges are really just, to see approximately what's going on, but having this digital display right in the middle of the instrument cluster will make it easy to see what's really going on battery capacity or voltage or current. Here's a nice little display that I'm going to replace the clock in the tachometer with. It comes from a company called SparkFun. It's a 4-digit fully programmable serial interface. Do all the numbers as both periods, decimal points, and colon, so it actually could be a clock too. The back of the instrument cluster has connections for everything, including all of the idiot lights, and I think I might actually have a need for this one. You can't see that. Yes, battery warning light. In the process of trying to find out where the tachometer signal is coming from, I took apart the actual ECU of this old car. Just what it's called the Jetronic, and actually controlled everything in the ignition system that could be controlled. But it's all, you can see, discrete components. It might be some kind of microprocessor in here, probably not very sophisticated, but I'll show here on the screen. This is what it actually did. It controlled all these modules basically with discrete components, no real logic signals like we have today in modern cars with ECU. Very interesting. Yeah, unfortunately, these aren't that rare or valuable. I've found that they're going for as little as $10 on eBay. Here's a look at some battery box designs. This is the design for the front battery box. These drawings were done by my good friend Mark Schufelt, who is a very talented mechanical designer and draftsman. And so this shows the front box that's going to hold 18 cells in a single row, and this will sit in front of the DMOC and the motor, and right behind the cooling system for both of those things. Here's the design for the battery box that's going in the back seat where the old gas tanks were. And here this shows 2 rows of 12 cells each. There'll be 2 boxes like this, one on each side of the drive shaft. And there's also a top lid to this that should help to support whatever kind of seat I can put there. Here's the design for the rear or trunk battery box. It's going to hold quite a few batteries. It's 3 rows of 18, and this is going to be the most significant weight in the car, but it's the only thing that's in the rear of the car, so it should balance out very nicely with the weight of the motor and the inverter and everything else that's in the engine compartment. So pretty cool. All those gauges in the instrument cluster are all galvanometric, which means they can be driven by the pulse width modulation, and that means I can have analog gauges that pretty much read out everything. Battery temperature, I can use the fuel gauge as a watt meter, an amp watt meter, and the digital readout in the tachometer will also be able to accurately read out those numbers. I think I can also, I'll use the tachometer not only for motor, but as a precise gauge for things like current or voltage, and that should, really work out well. As you can see, battery boxes are going to have a real nice designs. Again, those went out for fabrication last week, and they're promising them in 2 weeks. So we'll see how those work out. And next video should have maybe more of the car done. See you then.